Hello and welcome to today's live stream with NetApp, Leveling the Playing Field. I have a couple of very special guests with me today, and we're going to be talking about a fair few different interesting topics about cloud, around containers. But before I jump into that, I'm going to introduce my guests. The first person I'm going to introduce is Jason Benedicic, who is joining us all the way from Cambridge, United Kingdom. And by the way, I myself am based in Sydney, Australia, so it is all the way from the United Kingdom. Jason, welcome to today's NetApp live stream session. Thanks for joining us.
Hi, Chris. Thanks for having me.
Fantastic. Now, my other guest is not quite as far away as Jason is, but he's still fairly far away from where I am. He's based in Canberra, or Australia's capital territory, which is the capital city of Australia, for those of you who don't know. A lot of people think it's Sydney or Melbourne, but it isn't. It's Ryan Mills, a really good mate of mine, and a cloud engineer who works for one of the hyperscalers. Welcome, Ryan.
Hey, Chris, thanks for having me.
Fantastic. So I guess we should probably set the scene. We're all here to talk about leveling the playing field, so it must have something to do with games. But before I get into that, I'd like to get a little bit of background about yourselves. If you could tell me a little bit about yourself, because I guess we're all here to talk about cloud and we're here to talk about gaming, so they must have some sort of connection with each other. So let's hear a little bit more about you, Jason. Tell us a bit about yourself and what brought you here today.
All right, thanks, Chris. So Jason Benedicic, I'm an independent consultant in the UK, but well, I wasn't always this way. I started off in working in local companies here in the UK, but actually ended up getting into gaming quite early on in my career. So I ran massively multiplayer online games for a living. And then I've moved through to consulting and helping other companies on that journey of bringing up their infrastructure and bringing products to market. So yeah, a varied set of experiences across the world. And I'm an avid gamer in my spare time as well. So I play Warcraft, Overwatch, CS:GO, all that sort of stuff.
You said one of those magic words that gets me excited every time I hear it, CS:GO, which brings us to Ryan, a long-time friend of mine who I regularly play network games with on the weekends and things like that. And we have an interesting story to tell about what brought us all here together today to have this discussion. But Ryan, why don't you tell us a little bit about yourself, your background, what you do for a living, and what brought you here today as well?
Yeah, thanks, Chris. So yeah, Ryan Mills. I'm a customer engineer for one of the large hyperscale cloud providers. A bit of a technology geek, started in IT about 15, 20 years ago now, and started on the infrastructure side of things. And kind of what got me into it was early gaming. So one of the first network games I ever done was Doom 2, and that kind of really got me passionate about it. And then started with Quake, just playing with mates and friends using the old UDP networks and TCP networks and the old coax, and having to use terminators and things like that, and just kind of spawned from there and kind of turned a hobby into an actual career. So luckily enough, and I still game today, obviously with yourself and a bunch of others. So yeah, very exciting.
Fantastic. You said some other words there that got me excited as well. I haven't heard the word coax literally in decades, and that does remind me of the first network game that me and my friends played way back in the day. And in fact, I think one of the things that we all kind of got to sit back and appreciate is that the fact that we are globally dispersed right now, but we are talking to each other live with a live video feed. And as we're all kind of avid gamers and we're all kind of IT veterans, I think what better way to have this conversation than to play a game. So we've decided that today's game that we're going to play while we're having our discussions is Minecraft. And one of the reasons why we chose Minecraft is because some little known facts about Minecraft. It is the most popular game in the world. There are over 200 million copies sold, and that is no... I guess that is actually quite a huge achievement, in that the second place game has only sold 140 million copies and third place is about 100 million copies. But if I think back to the early days of the first network games, Ryan, you were talking about coax, and we're talking about Doom 2 and things like that. I actually remember, and I think a lot of folks who were born after probably 1995 or even maybe 2000 probably won't appreciate what it meant to get a LAN party up and running back in the day. So from an infrastructure perspective, first and foremost, we didn't have ultra-fast broadband connections from our houses connected all over the world. We probably didn't even have dial-up yet at best back in those days, but we did have rudimentary network connections. But that meant getting your PC or a bunch of people with PCs to one location to be able to physically get connected to each other within proximity. So as I mentioned before, I think no one born after 1995 will ever experience the pain of lugging a 17-inch or bigger cathode ray tube thick monitor. This is the days before LCD screens, people. Up 10 flights of stairs, then going back down to get your PC tower, which they literally weighed, a few fair kilos back in the day. Then your keyboard and mouse, then your speakers, then everything. And then once you're upstairs, correct me if I'm wrong, gentlemen, but there's always someone who messes with the network somehow. Either didn't bring enough cable or didn't bring enough components at the time. And even then, after you get all the network cables connected and you're playing these games, we're talking Command and Conquer 95, we're talking Doom 1, we're talking Quake 1 back in the late 90s, mid to late 90s, only to have someone trip over the cable and bring the whole network down in the middle of the game. So from those kind of humble beginnings, we're talking about infrastructure supporting our mission critical activity, which was network gaming. In your experience, Jason, you mentioned that you were working with hosting online games back in the early days. What did that look like from an infrastructure perspective?
So I started sort of late 90s, early 2000s, and hosting infrastructure was mainly local data center based, or sometimes your own office, depending on what you had. And so one of the games I ran, we had 30 plus physical servers, so at least a full rack per game world, and they were comprised of various different components. So you'd have database servers, front-end login servers, the actual servers that managed the various maps around the world and other components. And it was a really large undertaking. We had, multiple hour weekly maintenance for patching or other various sort of maintenance tasks, even upgrades of hardware or firmware and those sorts of things. So it was quite traditional. It's kind of what you would expect from the era, in that there was a lot of work involved, a lot of physical tin, and a lot of work to get a few 100,000 players in a game.
Wow. And what kind of era are we talking in here? What would you say the average home internet connection would have been back in those days?
Probably still dial-up in the UK. Maybe, yeah, probably still dial. Maybe some early broadband. So a couple of meg. Nothing too, too advanced like we have now. Yeah. And so I guess infrastructure itself has evolved over the many years. I mean, we are all gamers and we're talking about gaming infrastructure, but it's also quite relevant in the business world as well. When you think about in your specific scenario there, you had to build infrastructure so that people could play games together online through their connections for profit, I'm guessing, right? Yes. Yeah. Well, try to go into business to make some money.
Try to. So if you think about the back in those days, right, you had to get some planning for the design of some infrastructure to deploy, and once you get that done, then you need to find a data center facility to host it for the multiple connections to it. What would you say the time it took from inception of wanting to create this massive online game to having a fully racked, stacked, connected data center with gaming servers ready to go? What's that time period look like?
So actually, kind of leans into a good story. So at one point, hosting the game, we decided to relocate from the original data center, which was based here in the UK. So procuring new servers, setting all the design out, doing all the implementation and testing, migration of data, and all those sorts of things was a 3-month process at least.
3-month process.
Yeah, at least. And that was pretty quick for the time, because we were working with some good partners that already had a certain amount of hardware available for us. But if we had been purchasing it ourselves new as well, I mean, you probably could have said 6 months, I would have said, easily.
Wow. 6 months before you even get your first user on there playing a game. So I'd like to switch gears now and talk to you, Ryan, working for one of the world's biggest hyperscalers, and this infrastructure conversation that we're having. Fast forward to today, and what do you think is a typical lead time from the idea or the inception of, let's say, an online game through to that infrastructure becoming readily available to use?
Yeah, look, it's definitely stepped up from kind of months down to weeks, if not days. And then I guess a great example of that was one of the things we did recently around when we were playing an online game together, and we all decided to potentially level the playing fields a little bit more around some pings and set up a game server online. And again, look, we had that up in about 10, 15 minutes, Gondek, with just a simple container running on one of the cloud's hyperscale providers. So.
Yeah, and look, you make a good point there. So the idea was we needed to host a gaming server somewhere that was equally accessible from all of the players. So what we're talking about today, this leveling the playing field, is let's say you're a business and you have a situation where you want to deliver your services globally. This is quite a common theme these days. And typically in the past, you would have to deploy a data center somewhere with some genuinely great high-speed connections. Now, with the advent of public cloud, you have infrastructure as a service available for an immediate subscription. So for us, when we're playing games and we're distributed across the globe, just like a business is, there was kind of an unfair advantage for the players who are hosting the server in their location. I'll give you an example. We're all here in Australia. Well, 2 out of 3 of us are in Australia. So when I create a server that for Ryan to join, his ping time or lag time, as your kids will tell you, is very important. He'll probably be in the, what do you reckon, Ryan, into the 50 millisecond kind of ping time?
So look, it should be about 15, 10.
Yeah. 10 to 15, up to about 50 milliseconds. But then our friends all the way over in the UK and in Switzerland and even the US would typically experience somewhere around the 300 millisecond ping time connection to the server. Now, any of you who have played a game that requires breakneck speed and quick reflexes will tell you a lag time of 300 milliseconds is literally the difference between virtual life and death, right? What are your thoughts on this, Jason?
Yeah, I mean, I play some games with friends on the east coast of the US, and I think that's probably the closest long distance that I'll get, and even that's 150 milliseconds. If we go to the other side of the US, it's 500 plus. Down to you guys, could probably be over 1,000. As gamers, we all look for better hardware, better internet connections, faster response times from the peripherals, the lowest millisecond latency in the monitors. If you then have all of that available to you, but then you've got a 1,000 millisecond connection to the server, by the time I've performed the action, you're somewhere else. You're in a different place on the map, or there's no comparison with losing that kind of time.
So this is our dilemma that we're facing. We are globally dispersed, and we want to be able to play equally. How are we going to find a ping time that matches all our needs? It's not like we're all in the same neighborhood and we can lug our PCs and physically connect them with cables. We're all over the world. So we need to find a place to, I guess, centrally host our gaming server. And I remember actually, Ryan, you told us about a really cool utility called GC Ping. And GC Ping happened to show us the latency from our locations, our individual locations, to all of the cloud-hosted facilities around the world. So the first thing we did was everyone ran the GC Ping utility to find what is my latency from my location to all these different hosted facilities. And then we could compare the results and determine, okay, what is the fairest location for us to host this gaming server? And I believe it was the West Coast, Oregon or something like that, was equal around 150 millisecond ping for everyone. From the UK, obviously the US was a bit faster, from Asia, from Sydney. This finally leveled the playing field. And what that does is then solve the latency issue. So everyone's got the same advantage in terms of being in the game and shooting each other. But then that left us with another challenge of, okay, we know that there's some cloud infrastructure there to put the server into. What does cloud infrastructure look like? And how do we deploy that gaming server into that cloud infrastructure? So Ryan, I'll turn to you for this one. What are the kind of options that we have in a hyperscaler when we look to deploy something into infrastructure?
Yeah, thanks, Chris. So I guess we've got your traditional deployment methodologies around kind of the IaaS stack or your compute instances, where effectively you deploy a operating system to that compute instance and you're responsible for that operating system, which is, again, incredibly flexible with kind of the control and what you get access to do in that particular instance, but can be cumbersome from a management standpoint. And I guess it's a perfect example back to our gaming scenario where it's like, we didn't want to have to spend the time spinning up those resources, installing operating systems, getting the game downloaded and installed for then only to kind of use it for an hour or two and then kind of kill that instance a little bit later and then have to come back and do all that over again. So we kind of opted for a compute instance, sorry, a container-based instance or Kubernetes-based instance, and used a managed Kubernetes instance for that as an example. And we're able just to find a real simple online pre-built container that someone had already built, and then just deploy that. And in that instance, we were up in what, 5-10 minutes. We had basically a CSGO server running in that region within the data set, within the cloud-hosted platform. And we're able to all connect into it and start playing. And then, yeah, the beauty of that, I guess, is you kill the container and then come back a week later and we can just spin it up again from that standpoint, and really flexible around that deployment time and kind of flexibility around where around the world you can deploy, because you're not hamstrung by that infrastructure like we used to be back when we used to play games in the early days.
Yeah, look, you raise a really good point there, Ryan. So once we decided that we would use a cloud hyperscaler to host our gaming server, it was then a choice of, you know, what flavor of infrastructure would you like? Is it going to be a virtual machine or is it going to be a container? And I think a lot of businesses are faced with this, I guess, choice today. And there are benefits, I guess, of both deployment models. You know, you talk about containers and the way that they can kind of be spawned and destroyed just for their purpose of use. So that significantly reduces cost of infrastructure. And I think as, you know, as dads with mortgages and stuff like that, I think none of us were really willing and prepared to fork out our credit cards to pay for that cloud infrastructure up front, right? We thought there was a cheaper option like deploying a container. I think that became immediately the more popular one. And it's the same in business, right? If there is a more cost-effective option, if I can deploy my application in a cloud-native microservice architecture fashion like a container, then I'll do it. In fact, in our scenario, as you mentioned, Ryan, there was a pre-configured and pre-built container ready to go. Now, this would be fundamentally smaller than a pre-configured virtual machine. We've all heard of virtual machine templates that we can deploy from and things like that. So I guess, you know, we're getting further towards the solution to our challenge. We're a globally dispersed playing force. We found a central location for our gaming server to be hosted. We decided that we're going to use a container over a virtual machine because of its portability and its ability to kind of get up and running quite quickly. But just like a business, and with business applications, our container was unique in a sense that we wanted to download some custom maps that we like to play. We wanted to put some settings into the game that we like to keep because, you know, we play a certain way and we want certain, you know, max players to join and things like that. So we're creating changes that if that container disappears, the changes go with it. And this is something we refer to as persistent data. And this is a challenge that a lot of businesses have out there as well. When they're thinking about adopting different types of virtual infrastructure and microservice architectures, as more and more of the infrastructure layer becomes abstracted away from us, you know, we're buying infrastructure as a service. We're buying, you know, even container as a service with Kubernetes engines. The only asset we have left is our data, and the residual data, or the, I guess, persistent data that we want to keep. So how would we overcome the problem of deploying a container, but keeping any changes that we make in that container's activity, or even surrounding containers activity? I'll look to you, Jason. What are your thoughts around this? So,
I mean, in previous iterations of infrastructure, we've kind of always had disk, SAN, or NAS available to us, you know, and your virtual machine has got some form of storage available to it. So just to be clear, when we're talking about SANs and NASs, we're talking about network attached storage, storage area networks, local storage, right? Storage that was abstracted from compute in those days. Yes, that's correct. Yeah. So, you know, we kind of took those things for granted, and then we moved onwards, and a lot of the initial kind of use cases for containerization and functions and other, you know, advanced compute features were more stateless. But as more and more enterprises have taken, you know, that step forward, we're finding that we do need what you said, persistence, and there are a number of players in the market moving into this area where we can offer the same levels of persistent storage from those technologies that you are used to. You know, your SAN, your NAS, and another. They're being offered now in the hyperscalers and in the cloud providers, and with the same levels of automation and abstraction that you get from the hyperscaler. So you don't have to be a traditional sort of storage admin. You could come from a different background, and you can integrate the kind of shared storage model, or, you know, dedicated storage, and introduce that to your containers. So in our example, we're looking at attaching a persistent volume claim to a container so that we can store our metadata, our database effectively of you know, who's won what games, what the leaderboard looks like, what our maps are, and those sorts of things. They can all be stored there, and, you know, even if the container goes away and we blow another one up the next week, the back end data can be claimed back and move forward, and we can keep that data with us. So you raise a really good point there, and I guess you know, there was a bit of method of madness to my question there. So let's paint the picture again. We're globally dispersed gamers. We've picked a central location on a hyperscaler to host our gaming server. We've chosen a container because we found a pre-configured one that was super fast to deploy in a infrastructure as a service environment that's very low cost, and will only be charging us for while it's up and running, while we're playing network games on a Friday and Saturday night, and then it will go to sleep when we're not using it, and therefore costing us little to no dollars while it's offline, or pounds even. And then we fire it back up again the following week, and all our changes are there because of the persistent storage. So what persistent storage service are we using? If we're thinking about containers, traditional infrastructure folk who have been used to managing storage on premises in a data center, and now in a cloud environment, and they've kind of got storage on tap, right? They can just switch it on. You know, obviously today it's a NetApp live stream session. We want to talk about NetApp technology. In terms of being able to provision persistent storage to a container, would you say that there's a fair amount of skill sets involved there, Jason? Is that something that would be complex if you wanted to do it manually? Yes. So there are, I've had to learn Kubernetes and other container-based abstractions manually and learn them the hard way, just so you can understand them. And yes, it can be complicated. There's a number of steps involved, and there are restrictions or caveats based on what kind of storage technology you pick. If you've got storage that's local to your node, you're not going to be able to share that with containers running on another node. If you're using certain types of storage protocols, SMB rather than NFS, you're going to get some form of performance limits. And there's a number of different considerations to take when you're doing it manually or just using what's available natively within the sort of the hardware in the cloud.
Interesting. So you mentioned some really interesting points there. Storage protocols, presenting storage to the container in the location that it's in. I'm guessing that from a business perspective, there'd probably be some security and performance implications there and requirements. And why wouldn't we want some of that as gamers? Why would we want ultra fast storage? That is obviously still kind of somewhat protected from cyber threats and things like that. Ryan, in your experience, I guess, working for a hyperscaler, in terms of the native offerings within the hyperscaler, would you say that a lot of them kind of tick enough boxes to be kind of good enough from these persistent storage needs and performance needs? And how do you think like a technology like NetApp would kind of differentiate from what the cloud storage offering has?
Yeah, look, I think to the point around containers, providing that flexibility and portability, and that's the whole advantage of kind of running with the container-based service. The cloud storage providers obviously all have their own storage options in that, which are great for using those particular services. But again, to, I guess, Jason's point, where you might want to have multiple different protocols running and not all cloud providers can provide that. Or again, just to take back from an on-premise standpoint, where you used to have multiple different versions of things running on-premise and you'd kind of have to present storage to that. From the NetApp approach, it kind of gives that flexibility to be able to present to all of these different cloud providers and have a homogeneous environment across all cloud providers. So you don't have to, I guess, teach your NetApp administrators, GCP, Azure, and AWS, they kind of just are able to log into their NetApp console and able to provision storage across all three platforms in a really simplistic way, giving you that data portability across all cloud platforms. And providing you the flexibility around being able to move data around those cloud providers independent of their individual services.
I love that. So if I'm really cheap and I find that the cost of my container is $2 on Friday night in GCP, but it might be $1 on Saturday night in another cloud provider, I just, I can rip it out, put it somewhere else. From a business standpoint, that's actually, quite an attractive feature, isn't it? But obviously, in terms of, we're talking about businesses again, and we've got this persistent storage. Now it's high performance for us. Now we've got some protection and recovery mechanisms built into it. Let's say that your challenges of hosting a gaming platform, Jason, from back in the day, were today's challenges. Now you suddenly have the cloud. Now you suddenly have containers. How much easier would your life have been if you had today's technology and options? Oh, you're on mute. It's 2021 now. I thought we got past being on mute.
Always somebody on mute. Yes, this time it was me. Okay. Yeah, so infinitely easier. There are a number of areas, and I'll start with like the first one, startup cost. When I worked in this industry, we had a lot of investment to become a startup business. There's a lot of cost in the infrastructure, in the hosting providers, in the internet connections. And other staffing costs and things like that. So the barrier to entry is quite high. If I was starting again now, I could probably start on my own with a very small amount of money. And you can scale as things as grow. So, we had to put in place an amount of hardware for our perceived, what we thought we could reach. We knew that we had a certain number of signups and registrations, into the well over 1 million anyway. And then we had to work on, okay, how many people do we think are going to play at any one time concurrently, and build an infrastructure that could cope with that. And you have to build for the highest demand, not your average. So we would spend and build extra capacity to deal with that demand, but that might only be 10% of the week. So now if I was doing it now, I could have all of the elastic scaling of the cloud and of its compute and storage, and say, okay, I'm going to start with enough to provide for 100 users, and if I get 100,000 users, the system's going to take care of that for me. Wow. As long as my design is right, I can do that. So, the differences are night and day compared to what I was doing back then. As if I was doing the same thing now, it would be a very, very different story.
So you mentioned startup money. You kind of had to be prepared for predicting just how big you're going to get. You talked about 1 million users. Cloud brought us this kind of concept of elasticity. And especially if you adopt a microservice architecture in the form of spawning containers. Ryan, could you give us an idea of the scale that cloud can get to in terms of scaling and auto scaling?
Yeah, look, there's a lot of great services online from a cloud perspective that are well known from kind of launching and killing containers. I guess some of the services of the bigger hyperscale cloud providers are launching kind of upwards of 3,000 containers a second, and launching and killing 3,000 containers a second, to, I guess, event-driven notifications now, with a lot of publish subscribe-based notification services kind of pushing upwards of 20 to 50,000 kind of notifications per second, and that, so it gives you that flexibility. And I guess, look, playing Minecraft at the moment right now, here's a perfect example where, look at this game, you never would have thought it had been successful as it was, and kind of we look at it and had a bit of a joke at kind of when we first started playing it, and then it becomes addictive. So then when you first build Minecraft from that standpoint, how are you to know how successful it's going to be? And to Jason's point, you could start with 100 users, and then overnight, before you know it, go to kind of 1 million or 100 million users. And another great example of that was, I guess, was Pokemon Go. Whoever thought Pokemon Go would be as successful as what it was, but they were able to meet those demands through using some of the cloud hyperscale providers to kind of meet that overnight success.
Actually, you've just raised a really good point. You've triggered my memory. Pokemon Go. When I think about the value of data, and look, it was an absolute great explanation there, Ryan, on the scalability and elasticity of cloud. You can kind of fail fast. You can build for 100 users, but know it can scale to millions of users. The infrastructure will kind of accommodate that, if your code accommodates that. But thinking about Pokemon Go, you heard me talk about earlier that when we start to adopt infrastructure as a service and go into microservice architecture, and then there's that persistent data is the only kind of asset we have left. That's the important thing to us. And we'll put that persistent data into repositories that can be snapshotted and protected for potential recovery purposes or audit purposes down the line. I remember a time when I used to go on business trips to exotic locations. I was quite lucky, and my kids would ask me to bring them back something. In fact, I remember, when I was a kid, I'd see other kids' parents come back from overseas and bring exotic shoes and exotic chocolates and sweets and toys and things like that. And I remember the day when one of my kids said to me, I'm going to New Zealand, and I'm going to be in New Zealand for a week or so. And I'm like, what do you want me to bring back? And my kids started talking about, you need to bring back this Pokemon character. And I'm like, okay, which shop do I buy it from? And they're like, oh no, you don't buy it from a shop. It's not a plush toy or something you can bring back. You actually have to go to this location, open the Pokemon Go app on your phone, and you have to throw this ball at it to capture it. And they wanted me to bring back this virtual creature. And that's when I kind of realized that even my children are placing value on data over things, just like businesses do today. So Pokemon Go was a great example of how this digital economy has kind of come about. I think earlier tonight we were even talking about virtual real estate being purchased up with cryptocurrencies and things like that. So I think the dependency on infrastructure isn't going to slow down, both for us gamers and for businesses. The infrastructure offerings that we have available to us is just staggering now. We started talking about virtual infrastructure as virtual machines and virtual private clouds, through to container engines and Kubernetes, through to the persistent storage and the automation of that whole process and the elasticity of that process to serve all these serve all these needs today. So if I could ask at this point, what do you think the future holds for public cloud and gaming and business? Ryan, I'll get your thoughts first. Where do you think we're all heading?
Yeah, look, I think it's a definite large transformation in the next kind of 10 to 20 years. I think back when I first started in the industry, where 20 years ago, I remember when VMware first started and virtualization was a huge thing, and there was a big shift there. And kind of you started to roll that in the development environments, and we've seen it going to now full-blown production, and some might even say VMware is now legacy. I think cloud is in that early infancy of kind of moving into developers, and it's kind of exploded now. And it's going to definitely be the technology of choice for the next 10 to 20 years. And then where to from there, I don't know. I think quantum computing and kind of thinking much further ahead from that standpoint. And I think I can't wait to see that as to what's going to be the next big explosion after cloud. So yeah, so that's my thoughts on it. Jason, what about you?
So, I mean, looking from a gaming standpoint, the cloud has changed a lot of things. I've been a long-term player of games like World of Warcraft. And that's 15, 16 years old now, and every expansion I've seen launch has had a better experience. And I know that Activision Blizzard have got deals in place with Google for the cloud platform, and no one ever expected something like World of Warcraft to be as successful as it was, or still be running 15, 16 years later through multiple expansions. And, on an expansion launch night. In the older days, it would be servers would be down, or there'd be, queues and huge problems. And each iteration and each adoption of new cloud technologies eases this and makes it better. And the same with their console launches like Call of Duty and those sorts of things. They're getting better every time. So I think what's happening here is that greater adoption of the cloud is really giving us flexibility in how we approach solving business problems. That's only going to get better, and I think we're only going to do more in terms of distributed computing as well. So, we build systems in data centers, but I think there's a huge push now with more IoT and edge devices and more compute and storage at the edge and those sorts of things. So over the coming years, I think we'll see the cloud extend its reach, probably even into, your traditional on-premises data centers, where we're seeing some of that already with some of the technologies from the hyperscalers, but I think there's going to be more of that. And then just more connected devices. We've got connected cars, watches, so on and so forth. I think as technology gets better and the processing and power in your connected devices gets better, you're probably going to be able to do a lot more in those areas as well. So I think it's all just going to get bigger. And better.
Absolutely. Bigger, better, badder. And I mean, look at this game that we're playing, Minecraft. I mean, my children play this game. My children create virtual worlds on virtual servers, on infrastructure as a service environments. I mean, even the person that packaged up the container that hosted our gaming server is probably someone who has developed those skills only in the last few years. And look at the playing field that they have. We didn't have this playing field 25 years ago when we started network gaming. The playing field today is infinite in its reach, in terms of scale, in terms of speed, in terms of agility, and in terms of what's possible. I expect to see when's the Minecraft 2? What's the next Minecraft going to be, where all these people get on and play and get really engaged, and in business as well. What's kind of going to be that next cloud technology? From my perspective, I'm very excited about what the future holds, and speaking from a NetApp perspective, where we are absolutely cloud storage specialists. We like to be able to be the technology provider to enable this activity, to enable that speed and agility, to enable that persistence and protection that our users are going to be demanding from the hyperscalers. Yeah, so if I can throw in a cheeky plug, because I am here representing NetApp today, we want to talk about a special that we've got going right now. If you have enterprise workloads on Google Cloud Platform, or you want to migrate and run your enterprise workloads on Google Cloud Platform or other cloud providers for that matter, we can help you reduce infrastructure costs by up to 70% with a no-risk 14-day trial. You get $1,000 worth of what we call NetApp Cloud Volume Service. That NetApp Cloud Volume Service is what gives you the persistence, the performance, the multi-protocol, all of the things, all of the challenges that we were talking about that you can sometimes run into out of the standard public cloud infrastructure. So get out to cloud.netapp.com today and check out that free trial that we've got going there. But just before I wrap up, I'd like to give a huge thanks to my guests tonight. Jason Benedicic, all the way over from Cambridge, UK. Thanks for joining us tonight.
Thanks very much. It's been great.
And yeah, I appreciate you sharing your insights and of setting up and running gaming servers all the way back from the dial-up days. And also, Ryan, thanks very much for joining us. I look very much forward to playing again on our cloud-hosted server with our leveled playing field ping times and all of our friends from around the globe.
Thanks, Chris. Thanks for having me. It was a pleasure.
Fantastic. All right, folks. Well, that's all we've got time for tonight. Tune in next time for our next live stream. But in the meantime, get out there, get into the cloud, start playing with these containers. And when you're not doing that, make sure you're jumping on those gaming servers on the weekends and getting those low latency, low ping, high scores that we're all after. So thanks again for joining us, and see you on the next webcast.